How to optimize a dowel design. In this video, we'll walk through the process of using American Highway's Dowel Optimizer to perform an efficient and accurate dowel design. Whether you're optimizing for a new project or reviewing a saved report, this tool makes the process quick and intuitive. Let's get started. The Dowel Optimizer can be accessed at design.americanhighway.com. If you don't yet have access, click on the Request Access link. If you already have an account, simply enter your email and password, then click Continue to log in. Most users come to this tool to start a new Dowel optimization. However, if you're returning to access a previously saved report, click the Save Reports button. To start a new optimization, enter a project name and click Start. If you'll be working with metric units, toggle the unit system before proceeding. You'll now enter general project information, including the owner or agency, project size, and location. Once this information is complete, click Continue to proceed. This section focuses on the traffic loads as the Dowel Optimizer was specifically built for vehicular applications. The load input refers to a single wheel or tire. For this example, we'll use 4,000 pounds. Each screen includes a sidebar guide with helpful notes. You can toggle this guide on or off at any time. In our scenario, we're using small, hard wheels like those found on a pallet lift truck, where shore hardness is a key factor. With this selection, the joint differential deflection limit is reduced to 0.01 inches, guiding a more conservative design. We'll space two 4,000-pound wheels 18 inches apart. For the wheel width, we'll enter 3 inches. The wheel length is unknown but visibly less than 0.5 inches. To be conservative, we'll input 0 inches. With all load inputs entered, click Continue to proceed to the Structure section. This section defines the support, concrete properties, and slab geometry. We'll use a 7-inch thick slab and a 15-foot joint spacing. The support type is an unstabilized aggregate base. Based on the geotechnical report, we'll input a modulus of subgrade support, a K value of 100 psi per inch. For concrete strength, we'll use 4,000 psi and select a normal shrinkage of 500 microstrain. With these inputs defined, click Continue to move to dowel options. Since we're exploring the best alternative, we'll select all dowel types. You can easily deselect any options you're not interested in. Click Run to perform the optimization. It only takes a few seconds. With the provided inputs, the optimized designs are round dowels, 3/4 inch diameter at 18 inches on center, a wider spacing than typically suggested by ACI. Single taper plate dowels, 3/8 inches at 18 inches on center. Double taper plate dowels, 3/8 inches at 15 inches on center, 3 inches closer. Diamond shaped plate dowels, 1/4 inch thick at 30 inches on center. From this view, you can click on any design to review its specific results. For more on this, see our video titled Understanding the Results. You can return to the optimization summary or click the icons in the top menu to revisit project info, wheels or tires, structure, or dowel options to make adjustments. Then, continue and rerun the optimization. With fewer than a dozen inputs and just seconds of processing, the tool provides multiple optimized dowel alternatives, which can be saved as a PDF or stored in your saved reports for future reference. It's that simple and efficient with dowel optimization at your fingertips.